One construction we did not look at in sections 2 and 3 was a triangle mid-segment construction. So section 5.4, the triangle mid-segment theorem, we're going to look at that final construction and the results of that. So a mid-segment is kind of what it sounds like. It's a segment that joins the midpoints of two sides of a triangle. So we see tick marks here that mean that X, Y, and Z are midpoints of the three sides of triangle PQR. So those mid-segments, XY, YZ, and ZX are all mid-segments. They connect the midpoints of the sides of the triangle. And what they do is they create their own little triangle in there. The mid-segment triangle, triangle X, Y, Z. Now some pretty unique things happen, and I imagine in just looking at this diagram you might be able to start to make some conclusions about what's going on. But let's look at an example of coordinates here. The vertices of triangle XYZ. X is at -1, 8. Y is at 9, 2. And Z is at 3, -4. So X, Y, and Z. There we go. Now it says M and N are the midpoints of X, Z, and YZ. So M is the midpoint of XZ. So the midpoint looks like we're going 4 units over, so halfway between, 2 units between them. And then it looks like from 8 to -4, that's 12 units, so 6 up. 1, 2, 3, 4, 5, 6. And M is that midpoint, M. And then N is the midpoint of YZ. So it looks like YZ from 3 to 9, that's 6, so 3 units over. And then from -4 up to 2, that's 6, so 3 units up. There we go. So we have that mid-segment, MN. All right? So X is at -1, 8. Y is at 9, 2. Z is at 3, -4. And then we have M at 1, 2. And N at, well, 1, 2, 3, 4, 5, 6, -1. So show that MN is parallel to XY and that MN is equal to 1/2 of XY. So what we're looking at is some coordinate proof. Coordinate proof means we are using algebra, okay? Going to be using formulas. So it looks like we're using, we want to show these lines are parallel, so we're using some slope formula. And then we want to look at their distances, so we're using distance formula as well. So the slope of line segment MN, that's going to be y2 minus y1 over x2 minus x1. So let's say this is the first point, this is the second point, y2 minus y1, -1 minus 2, over x2 minus x1, 6 minus 1. And then we'll look at the slope of xy. All right, same formula, y2 minus y1 over x2 minus x1. Let's say this is our first point, this is our second point. So 2 minus 8 over 9 minus -1. So let's see what happens. We get -3 over 5, and here we get -6 over 10, which reduces down to -3 over 5. So we got the same slopes. We showed that they're parallel. We can check that off. So now looking at the length of these segments, looking at the length of XY and the length of MN. Now you have a couple of options. You can use distance formula or Pythagorean theorem. Now distance formula is pretty helpful when you have coordinates, which we have. Pythagorean theorem is helpful when you have a picture, which we have. And in my opinion, Pythagorean theorem is a little easier to work with. Since we already have the picture, let's go ahead and use Pythagorean theorem. And let's set up some right triangles. So from -1 to 9, we have 10. And from 2 to 8, we have 6. Here, from 1 to 6, we have 5. And right here, that's going to be 3 units. So if you look here already, you see 10 and 6. Cut those in half, 5 and 3. You know, I bet the hypotenuses are going to be half as well. So xy will equal the square root of 10 squared plus 6 squared. Mn is going to equal the square root of 5 squared plus 3 squared. So 10 squared is 100, 6 squared is 36. We get the square root of 136. 5 squared is 25, 3 squared is 9. 25 and 9, root 34. Now this square root of 135, you can plug these into a calculator, get a decimal approximation, see what that ratio is. I'm going to use simplest radical form. 136 can be divided by 4. That leaves you with 34. Now the square root of 4 is 2. When I put these back together, I have 2 root 34. So I have 2 root 34s. I have half of that, 1 root 34. So we showed that Mn is equal to half of xy. So what we've done is we've shown a specific case of the triangle midsegment theorem. The triangle midsegment theorem states that any midsegment is parallel to the side it does not intersect, and then it is also half the length of the side it does not intersect. So you get that parallel, and you get that half the length. So take a look at examples 2 and 3 at the bottom of the page. You can check your answers with my completed notes online.